Welcome to lesson 63, Math Marbles. We're going to look at one-step equations with inverse operations. We're finally going to start solving. So as I work through these problems, here are the things that I want you to be on the lookout for. I want you to really look at how I use inverse operations. Inverse just means opposites to isolate the variable. I want it by itself. So watch how I'm going to do that. And there are two things you're going to see me do. The first one is if I have a plus or a minus, I'm going to create zero pairs. So that's the first one. I want you to watch how I create zero pairs to get the variable by itself. Or if there's a coefficient, how I use division to actually separate it from the variable. So just be on the watch out for that part. Then I want you to notice how I keep balance throughout my work by making sure whatever I do to one expression, I got to do to the other. So it keeps balance. And I always check my solutions using substitution. Math Marbles, we're going to start solving simple one-step equations. Some of this is your mind's just going to see the answer, but I'm going to purposefully slow down our thinking so we can think about why it works and create actual structures or finding the answer that makes sense. So here's our first equation. We have d minus 5 equals 7. So just looking at it, a number minus 5 makes 7. Automatically, I already know what you're thinking. It's 12. 12 minus 5 is the only number that would make this true. Yes, and I want us to start thinking algebraically, and we're starting with simpler problems to think of more complex mathematics, okay? So we're starting simple so you can see the algebra behind it that you will use with more complicated numbers. What I'm going to do is create a visual for this, and we're going to pretend that we have some number, and I have some number over here. I have no idea what that number is. I'm going to use my counters. So that's what we have on one equation. On the other side, I have 7. So I have 7 positive numbers. So think of these like the two color counters there in your classroom. I'm going to make the positives yellow just so we can see them. Now, what do we know about our integers when we have positive and negative numbers? We haven't done these in a while. What happens when we add two opposites, a positive and a negative? So when I have -1 and a +1, when I bring these together, I'm going to get 0. So it's been a minute since we've done these. These two together, when we combine them, make a 0 pair. It's kind of like I have $1, I owe $1. I have nothing now. So a -1 and a +1 make nothing. What we want to do, what the mathematics that we're going to learn how to do is we want to what's called isolate the variable. We want this d exactly by itself. That's what we want. So we're going to call it like an isolation. And the way we do that is we have to somehow get rid of these. We have to turn these into a 0. So that's what we're going to do. We're going to turn the numbers into 0. And this is concept right now. We're not going to do this drawing every single time. So how do I turn these into 0? By adding their opposite. So I'm going to add a 1, add a 1, add a 1, add a 1, add a 1. So when I do that, these are all going to turn into zeros. We're going to make a 0, a 0, a 0, a 0, a 0, which would only leave me with my d. So see how I isolated the variable d? I had a number here, and I got rid of it by creating 0, by adding its opposite. Here's the thing about equations. Whatever you do to one expression, you have to do to the other expression. So over here, I added 5 to my -5s. That's how I made a 0. I'm going to do the same thing here. I have 7, but I need to add 5 to this. So 1, 2, 3, 4, 5. And these are all pluses. So when I had 7 and I added 5, they do not make 0 pairs because they're all positive. So what do you have? I have 12 on this side. So on one side, I just have the D, and on the other side, I just have 12. So D is equal to 12. This is how we solve one-step equations. So we're going to practice this. This is the visual way, and I'm going to hit pause so you can draw this out, and then I'm going to show you what this looks like algebraically. All right, let's look at what this looks like in algebra terms. Same thing, I still want this by itself, so I need to get rid of this. I have to turn this into a 0. So I'm going to add its opposite, because that's going to make 0 and leave me only with the variable D. But whatever you do to one expression, you're going to do to the other. And when I do that, I get D is equal to 12. See how much faster I was about the drawing? But the drawing is important because it helps us see why this is not magic. This is not a trick. There is actual stuff happening behind this. And even though we're thinking, why do I have to do this? That thinking of adding opposites is going to be real important when our numbers become more complicated. So here's our next step. We're going to go back to our original equation. D minus 5 equals 7. And now we're going to substitute our value. So D equals 12. 12 minus 5 equals 7. So this is true. So we always check using substitution. And it's a very easy way to actually figure out if we made a small calculation error. So hit pause and jot this down. Now that we have a better understanding of this, let's try it with another equation, also just adding. So here I have a number plus 8 equals 18. So again, I want to isolate, meaning I need to turn this into a 0 pair. That's my goal. I want a 0 pair. So I'm going to add its opposite, and that leaves me with just a variable P. And whatever you do to one side, you have to do to the other. That's what keeps it balanced. So I'm going to leave that as my little keyword balance. 0 pair and then a balance. 18 minus 8 is equal to 10. So P is equal to 10. Now we check. I go back to my original. P plus 8 equals 18. 10 plus 8 equals 18, and this is a true statement. 18 is equal to 18. So there you have it. Look at how quick and easy it is when we're going through it with adding and subtracting. This is what we're going to do. We're going to add and subtract to create 0 pairs to get that variable by itself. Hit pause and jot this down. We're going to try with multiplication next. Here's a visual for us. We're going to examine the tape diagram below and write an equation that represents it. On this side, we can see that these two rectangles are the same size. So this top one is equal to 70. And here we have a whole bunch of Q's, and all the Q's are the same number. So I have 1, 2, 3, 4, 5, 6, 7 Q's. So 70 is equal to 7Q. Okay, we still want to isolate this variable. We want to find what is the value of the Q. So we're still going to isolate. And in this case, I can't add or subtract the negative. That's not going to work here to make a 0 pair. But I do want the Q by itself. So what I'm going to do is I'm going to use division in this case. If I divide by 7, 7 divided by 7 is just going to leave me 1 Q. I don't remember, we don't always write the 1, but it's going to leave me just 1 Q, which is what we want. We want the Q by itself. Remember, whatever you do to one side, do to the other side. So 70 divided by 7 gives us 10. So each Q has a value of 10. Let's try this out with our check. 70 is equal to 7Q. 70 is equal to 7 times 10. 70 is equal to 70. And this makes sense. It is equal. And even in our visual, it helps. If each of these was equal to 10, we would have 10, 20, 30, 40, 50, 60, 70. So 70 is equal to 70. And this is how we would solve a one-step equation that has multiplication. Hit pause and jot this down. Let's use what we just learned about isolating variables using these two examples. One has multiplication and one has division. Again, remember, we want the variable by itself. So we'll start with the first one on this side. I want to get rid of this 12. And it's right next to being multiplied. So I'm going to use division. Let's divide by 12. 12 divided by 12 just leaves us 1t. And we do the same thing to the other side. 60 divided by 12 gives us 5. So t equals 5. We go back to the original for our check. 12 times 5 equals 60. Yep, 60 is equal to 60, so this one is correct. Now our second one is a little bit more complicated because here I have a number being divided by 8. So how do I get my number by itself? So watch this. I still want somehow to be an 8 over 8. So I am going to multiply by 8 over 1. I'm going to just multiply it by 8 over 1. Why? Because that's going to give me 8s over 8, which will simplify, again, to just 1s. That's the goal. Remember, whatever I do to one side, I got to do to the other. So my other side is just times 8 over 1, or just 8. And I'm getting 240. So s is equal to 240. Let's test it out. 30 is equal to s over 8. 30 is equal to 240 over 8. Yeah, 240 divided by 8 is 30. 30 equals 30. And that is done. So big takeaways. When we are multiplying, when you have a coefficient in front, you can divide by that coefficient to get your variable by itself. If your variable is being divided by a number, we can multiply by the reciprocal. So that's all I did here. I multiplied by the reciprocal. On this end, I just divided by the coefficient. And notice I'm still just using opposites. When I see multiplication, I divide. When I see division, I multiply. So I'm using an inverse operation. It's opposite to get that variable by itself. We're going to get a lot more practice with this, so hit pause and jot this down into your notes and take your time practicing this out and getting feedback from a partner or an adult. I'll see you in the next lesson, Math Marbles.